In this demonstration, we're going to be having a look at how we can simulate this basic tensile test of a piece of steel. So for this test, the base of our sample will be fully fixed and we'll apply a load of 1000 newtons to the far end. The specimen parameters can be seen here. So if we jump into Creo, you can see that I've already got this model generated. And if we have a look at the parameters, they should match those that we've said. Okay, so we've got a width of 75, a height of 150. Okay, and if we just edit the extrusion here, and our thickness is 10. So we've got our plate modeled within Creo. Now, in order to export it into Ansys, I need to go to a neutral file. So I'm going to go File, Save As, Save a Copy. And I'm going to change this to a step file. Step, you can give it a new name, but I'll just leave it named after its original part file. Click OK. So now I've got a step file saved. I now need to launch Ansys Workbench. So if I come down, I can search for it through the menu, or I can type in Workbench. Okay, so Workbench is just there. Okay, so I have Ansys Workbench loaded up. I'm going to start off with a static structural analysis. So if we have a look in the toolbox area on the left-hand side of the screen, these are all the different simulation types. And the one that I would like to use is static structural. So I'm just going to click it and then drag it into the schematic area. So I'm just going to check the engineering data. So if I double click engineering data, you can see that structural steel has been assigned. Now I'm happy to leave the material as it is for this case. So let's go back to the project. We're going to attach our geometry. So we're going to right click geometry, import geometry, browse. I'm going to look for my part file. Go to my desktop. There we go. And I've got my step file just there. So I'm going to import that. So now I've got a tick next to geometry. What we have to do in order to run a successful simulation is make sure we have a little green tick next to all of these cells within the project schematic. So in order to do this, we need to launch Ansys Mechanical. And to do that, we just right click here and go edit. This will launch the mechanical module from Ansys, and all remaining steps will be done within this environment. Okay, so the mechanical module is now loaded. We can get rid of this useful tips screen, and we can see that our geometry is being successfully imported. So if we come on over to the model outline, the first thing that I'm going to do is generate a mesh for the component. So we need to break it down into its small chunks. So if I click on mesh here, what you'll see is that actually the menu along the top changes. So anytime you click on one of these areas of the model, you'll see that the contextual menu will change. So just remember that, it's really important. Now if we click on mesh, we get all the information regarding the mesh. And the first thing I'm going to do is just generate a standard mesh. So I'm just going to click generate at the top here. Okay, so it's generated nice even mesh of this component. Geometry is very simple, so you can see the mesh is very uniform and it looks quite nice. Now what we could do, we could change the sizing of this. So if I click on sizing here, you can see that we add a new parameter into our mesh control. And what it's doing is it's anytime you see yellow in Ansys, so if we come down here, we've got details of this sizing, and you can see that it's looking for some geometry. So if I click here, I'm going to change my selection tool. So at the moment, if I look at the graphics toolbar, you can see that it's on face only. Now I want it to be on body, so I'm going to click body and then click on this body, and it should highlight the whole component basically. And then we click apply. So we've highlighted the component. Now what we can do is specify an element size. Okay, so the default element size for this is about 8mm. So let's cut that in half, let's say 4. And now if we go back to mesh, we can go update. That will update our mesh, and you can see we've got a much finer mesh applied to our component. Now, the thing to remember here is that obviously the finer the mesh, the more accurate your result will probably be. However, it will take longer to process. So FEA is a bit of a balance between the amount of processing power that you use and the ultimate accuracy of your result. So I've got a nice mesh, I'm happy with it. Now I need to apply my boundary conditions. So if I click on static structural here, you'll see the menu changes again along the top. And the first thing I'm going to do is apply my support. So I'm going to click on support, remote displacement, and then I'm going to click on this bottom face here. So you can see I've got surface selected and I can just click this face. And then in the details box where it says geometry, I will click apply. Okay, so I'm applying a boundary condition to this face. Now, the reason that I used a remote displacement was because it gives me a lot of control over the degrees of freedom that I'd like to limit. So if we have a look down in the yellow box here, at the moment, this face is able to move in all 6 degrees of freedom. Okay. Now, I want this to be fully fixed, so I'm going to change these all to 0. Okay, so they're all 0, so that means that that face on the bottom is not able to move in any of the degrees of freedom. So I filled in all the required information for this boundary condition. Now what I'd like to do is apply a force on this top surface. So I can click on force, click on the top surface, and then in a geometry selection, click apply. So when it says defined by, I'm going to change this to components. And so this means that I can now define my force relative to the coordinate system that's being displayed on the screen at the moment. Okay, so if I'd like it to be pulling upwards, that's in the Y direction. So I can put in 1000 newtons in the Y direction. It gives us a handy little arrow to show us the direction of the force. Okay. So if I click on static structural here, we can see that I have a remote displacement, that I've fixed all of the positions, and I have a force on this top surface. We're now ready to run the solution. So if I click on solution, click solve, Ansys will now generate a mathematical model and build the solution. Okay, so everything's successful. I've got ticks next to everything. Now we just need to do a little bit of post-processing. So find out the information that we would like. So if I click solution, again, the contextual menu along the top allows me to select how I would like to view the results. So the first thing we're going to have a look at is the directional deformation. So if we click there, if we have a look in the details, we can specify the direction we're interested in. So if I applied the force in the Y direction, that's basically the direction I'm most interested in. So I'm going to click Y there. And I'm also interested in the stress. So I'm going to click the equivalent stress here. So I've got 2 results here. We've got these little lightning bolts next to it. So that means that we need to do something to make these results work and be visible. So if I right click, go evaluate all results, you can see that we've now got a solution. So if we click on these, let's change our view up. So this shows us the deflection. And if we have a look at the units, so okay, the maximum deflection here is 0.01 millimeters. We can animate this, so we can see, okay, it looks about right to me. If you're applying force in that direction, you'd expect it to move in that way. Something to remember though, that this is an exaggeration. You know, we can change how much it moves. You can change it to undeformed, true scale. If we do true scale and animate it, you'll see that you can't actually see it moving. So you can change the scale. We can make it 5 times as well. So it just exaggerates the movement. So it can be useful for you. If we have a look at the stress, okay, so we've got 1.3 megapascals throughout the whole of this sample. Okay, so let's go back to the lecture and we'll be able to compare these results with the calculations.